So in today's lesson, we're going to be looking at the parameters of motion. Parameters of motion. And the first parameter we're going to be looking at is displacement. So displacement, which most times sometimes represented as S, is actually the distance traveled in a specific direction. So when you move a distance, so you do that in a specific direction. Let's say this is a boy. You ask the boy to move 30 meters. Yeah, this is a distance 30 meters, but you tell him in a particular direction. This is north, south, west, east, and tell him to move 30 kilometer due east. He's going to go like this. Okay, so this is displacement here. It has a direction east and it has a distance 30 meters. So this is what we call, this is magnitude, how far something should be. How far? 30, 50, 1 million, 10,000. East is direction. North, south, west, 30 degrees north, 50 degrees east. These are directions. So in this case, displacement is going to be considered a vector quantity. It's going to be considered a vector quantity. Why? Because vector quantities have magnitude and direction. So these are quantities that possess these two things, magnitude and direction. So therefore, displacement is actually a vector quantity. While distance, which is just basically just magnitude, this 30 meters, that's distance. So that's scalar quantity. They possess just magnitude but no direction. So distance is a scalar, while displacement is a vector quantity. All right, good. So the other parameter I want to look at is actually speed. So I represent that with V. So speed is the rate of change of distance with time. So that's V S over T. So displacement and distance are used interchangeably, but most times they are in physics they're actually two different things. So it's the rate of change of distance, the speed, with time, and it is measured in meters over second, right? This time measured in meter, time measured in seconds. So that's meters per second, or you write it as this, meter per second, ms raised to power minus 1, or m/s, as the case may be. That's the SI unit for speed. The SI unit for speed. Then you have another parameter, we call that velocity. And velocity is speed that is measured in a specific direction. So speed that is measured in a specific direction. So if I say a car moves with a velocity of let's say 30 kilometers per hour due south. So this is a velocity. Why? Because it has magnitude. This is speed. This is speed moved in a specific direction, south. This is direction. This is direction. Now that means it's telling me how fast I should go. This is magnitude. How fast I should go in a specific direction. Now, and velocity is going to be called a vector quantity. It's going to be called a vector quantity. Why? Because it possesses both magnitude and direction. Why speed is just going to be just magnitude, because it has just how much how fast I should go. Then another parameter I want to look at is the acceleration, which is actually a, and that's the rate of change of velocity with respect to time, and that acceleration is velocity over time, and the SI unit is actually meters per second over second, and that's meters per second squared, or I can write it as meters per second, ms raised to the power of -2, as the case may be. They're the same. All right, good. So these are the parameters that we're going to be using in motion. And before I close up today, I actually want to give you the 3 equations of motions that you might come across as we proceed in learning about motion. Equations of motion. Yeah, just 3 in number. Equations of motion. So the first is actually V equals U plus 80. Then the second is S equals UT plus half 80 squared. Then the third is V squared equals U squared plus 2GS. Now I know you'll be wondering that what is U, what is A, what is V, what is T. Let me just give you what they are. Okay, so V, where V equals to final velocity. V equals to final velocity. U equals initial velocity. Then what else parameters do we have there? We have A. I can see A. A equals acceleration. Then T equals time taken. And then the last one, we see S. S is actually distance. So these are the meaning of these parameters, that these equations that we have. V, final velocity equals to initial velocity plus acceleration times time. That's what is there. Then this S is distance covered equals initial velocity multiplied by time plus half of the acceleration time squared. Then this is final velocity squared equals initial velocity squared plus 2 times, oh, pardon me, where did I see G? Sorry, that was supposed to be A. That was supposed to be A, pardon me. So this is supposed to be 2AS. So that's final velocity squared equals to initial velocity squared plus 2 times acceleration times distance covered. So that's it. So we're going to be using these equations of motion to actually solve problem in our next videos. So watch out.